The James Webb Telescope launched on Christmas 2021, and the images that it sent back have not disappointed. In just 2 years, James Webb has already captured so many new discoveries that it's upending everything that astronomers and physicists thought we knew about the universe. So much so that scientists have even come up with new acronyms to describe these things that we're all seeing for the first time. James Webb Telescope makes jumbo discovery of planet-like objects in Orion. The Jupiter-sized planets free-floating in space unconnected to any star have been spotted by the James Webb Telescope. What's intriguing about the discovery is that these objects appear to be moving in pairs, and astronomers are currently struggling to explain them. The telescope observed about 40 pairs in a fabulously detailed new survey of the famous Orion Nebula. They've been nicknamed Jupiter Mass Binary Objects, or JUMBOs for short. And this is what we're talking about here. Look at these. These are pairs of gas giants like Jupiter, but they're not orbiting a star. And this article tries to explain it, saying, gas physics suggests you shouldn't be able to make objects with the mass of Jupiter on their own, and we know single planets can get kicked out from star systems, but how do you kick out pairs of these things together? Right now, we don't have an answer. It's one for the theoreticians. And the reason this is a big new discovery is that the only thing we know about gas giants really is what we've observed in our own solar system, mainly Jupiter. Now, Jupiter was actually created from the formation of our own sun. Jupiter took shape along with the rest of the solar system about 4.5 billion years ago. Gravity pulled swirling gas and dust together to form this gas giant. Jupiter took most of the mass left over after the formation of the sun, ending up with more than twice the combined material of the other bodies in the solar system. In fact, Jupiter has the same ingredients as a star, but it did not grow massive enough to ignite. So Jupiter is composed largely of the same elements as our sun, mostly hydrogen and helium. It just never got big enough to actually ignite into its own star, and if it did, we'd actually have 2 stars in our solar system. But the crazy thing about what these images that James Webb has sent back is that these gas giants don't appear to have been created in the same way as Jupiter. Look at these pairs. They're not actually orbiting a sun. They're just free floating in space. That's what's crazy about this discovery. Some of the other images sent back from James Webb actually show these right here. These are newborn stars that are making the next generation of planets. They're actually creating new planets. James Webb has also sent some crazy images back from the entire Orion Nebula. And these images in this BBC article actually puts this slider scale on here. So you can see if you just change the visible frequencies of light in shorter and longer wavelengths, you can see these changes from blues and reds to greens. And the longer wavelengths show these sculpted green clouds of gas that actually contain polycyclic aromatic hydrocarbons. And here on Earth, PAHs, or polycyclic aromatic hydrocarbons, are actually considered a stormwater pollutant. It kind of gets into the realm of things I specialize in my career. So all of these things that you're seeing in this green in this slider, polycyclic aromatic hydrocarbons, these are emitted from stars. It's pretty fascinating. And here's the other thing that deserves to be pointed out whenever discoveries like this happen. They really should almost never be surprising. And that's because we know almost nothing about the rest of the universe outside of our own solar system and what we've been able to explain through observations here on Earth. But we have no confirmation that the rest of the universe necessarily plays by all the same rules that Earth does. I'll show you what I mean. This is the James Webb Telescope. NASA actually built this really cool viewer. You can see it in relation to the rest of our solar system. And if you zoom out a little bit here, if you zoom out, you can see it's barely outside of Earth. It's just orbiting Earth right now. This is the most powerful telescope that we have right now, sending back all these images, and it's orbiting Earth just a little bit outside of our moon. But if you scale out just a little bit more, when you get close to the planet that's nearest Earth, Venus, you can't even see it in scale. You can't even see the James Webb Telescope. It's not even visible on this map. And that's the extent of the knowledge that we have. If you zoom out even further to the rest of the solar system, on NASA's viewer, you can actually see some of the other equipment that we've sent out. And the furthest that we have, this Voyager 1, right? Zoom out on the solar system. Voyager 1 is the first object that we have that's actually escaped our solar system and has reached interstellar space. And we launched this in 1977. Voyager 1 was launched almost 50 years ago, and it's barely outside of our solar system. And if you zoom out even further, we are just a tiny speck in the Milky Way galaxy, one galaxy among potentially an infinite number in our universe. That's like taking a sample of the ocean in a thimble and saying that you have enough data to understand everything that's in the ocean. We know nothing about the rest of the universe. So if we go back to that article, we actually have no idea what's going on here. Our data is very limited. The best we're able to see with our most powerful telescopes are these tiny little specks of light. That's really it. Everything we know about these tiny specks of light, about them being gas giants, is derived from theoretical mathematical models, theoretical physics, knowledge of some of the gas chromatography, like the colors that are reflected from different types of materials. So we can tell by the subtle color variations here that they're composed of different types of compounds. And then also where these tiny little specks are in relation to the other tiny specks. So we can see that the way they're grouped together in these pairs, and they don't appear to be orbiting any star, from what we understand of our own solar system, that's very unusual. But that's it. That's all of the data that the smartest humans on Earth have to work with. The most advanced technology that we have available to us, this is the only image they're able to return. Scientists always get eager when you come across something that you can't explain, because that opens up new frontiers for study. And that, I think, is why this is so exciting. But because we understand so little about the universe, we should not be surprised when our current physics models cannot explain things like this. And to keep it on theme with the rest of my channel, we should also not be surprised when our current physics models cannot explain some of these unidentified flying objects in our airspace that we have caught on camera with our equipment, the best available equipment that we have, and we still can't explain it. But I would love to hear what you guys think. For those of you that didn't get bored and click off of this video already, let me know in the comments below. Do you think this is a mind-blowing discovery? Or did you just forget to turn your phone off and you've already fallen asleep? Let me know in the comments below, and I will catch you guys on the next one.